Okay, geometry, welcome back. This is 4-6, isosceles triangles. Okay, last section in chapter 4 here, and we're going to use properties of isosceles triangles and equilateral triangles to solve some problems. So the first thing we're going to do is look at this isosceles triangle, and we're going to label it. Okay, so remember some of these terms from earlier in the chapter, that if we have an isosceles triangle, and let's call this part the base. So if that's the base, then that would mean that these are the legs. It'll be here and over here. And remember, those are the congruent sides. Would be the legs. So I'm just going to go ahead and put a dash mark here and here to show that they're congruent. And then we would have what we'd call, because this is the base, the angles. These would be the base angles here and up here. And then remember, the opposite angle up here is known as the vertex angle. Okay, so you have a vertex angle that's opposite the base, and you got your base angles, and the legs are opposite those, and the legs in an isosceles triangle are the congruent sides. Okay, so let's talk about a couple theorems with isosceles triangles. First, the isosceles triangle theorem, and that basically states that if two sides of a triangle are congruent, then the opposite angles are congruent. So if we look and say that these two sides here, if you look at vertex A and B, and those angles, if you look, it says if two sides of the triangle are congruent, then the angles opposite those are congruent. So if I look at, say, this side here and this side here are congruent, well then those angles opposite would have to be congruent as well. So angle 1 would be congruent to angle 2, because the sides opposite those are congruent. And then the converse of the isosceles triangle theorem, the converse of that is just stating it the other way. If you know that two angles are congruent, then the sides opposite those would also be congruent. So in this case, I could say that because angle 1 and angle 2 are congruent, then those sides opposite those, here and here, would have to be congruent. So DE would be congruent to FE. And you could go one step further and say, well, what if we didn't know those sides, and you said, well, this side was 4x plus 7, and this side was 3x minus 18. Well, then you could, of course, set those two sides equal to each other because they're equal, and then you could use algebra to solve. So you're going to see kind of some problems that are like that. Okay. First practice problem here just says name two congruent angles. Okay, so two congruent angles based on what we know. And because we know that in this case, if we know that this side CB here is congruent with this side here, then we know that the angles opposite those would have to be congruent as well. Okay, so what are the angles opposite those? Well, that would be angle A, right here, would be opposite of this one, right? Okay, and also this side here is opposite from angle C. So angle C would have to be congruent to angle A. And then they wanted to name two congruent segments. So we're looking at some angles that might be the same. So in this case here, we would say, let's look at the top triangle here. Angle D and angle, looks like C here, are congruent. So that would mean that the sides opposite those, this side here and then this side here, would have to be congruent as well. So I would say CB is congruent to DB. Okay. And then going further, we can solve more problems like this one number 2. I'm going to let you guys kind of work on this on your own. if you have x being the vertex of isosceles triangle XYZ, and then they give you the measure of x, and then they want you to find y and z. So in this case, you're going to use a couple different theorems: a triangle, sum theorem that they all add up to 180, and the fact that one of those angles is going to be 52 is going to be the vertex angle. So basically, y and z are going to split up the rest of that 180. We'll kind of talk about that in class if you can't figure it out on your own. The next one here would be number 3. We can look at this one. In isosceles DEF, D is the vertex angle. And this one might help you solve the number 2 as well. It's very similar. So D is the vertex angle. And then they give us the measure of angle E and the measure of angle F, and they want the measure of each angle in the triangle. So they want all 3 angle measures. So let's just start by drawing a picture. And I'm going to put D up here as the vertex angle. And that means that E and F can be down here. And if that's the case, if D is the vertex angle, then that means that these 2 legs would have to be congruent, because they would be the legs, which then also means that these 2 angles opposite those legs would have to be congruent. So now we are just putting in all the information that we know. We also know that angle E down here is 2x plus 40. This angle right here. And we know that angle F is 3x plus 22 right here. Okay, so now we can figure this out by saying, well, those 2 angles have to be equal, so I can set them equal to each other and say that 2x plus 40 equals 3x plus 22, and I can do algebra to kind of solve those. So I'm going to subtract 2x here from both sides. I'm also going to subtract 22 from both sides, and that's going to give me 18 equals x. So x equals 18. Now I'm able to figure out the rest of all the angles by plugging that 18 in. Okay, so I'm just going to write the angles over here, say angle D, angle E, and angle F, and then find out what their measures are. So I can plug the 18 in here, and I go 2 times 18 is 36, plus 40 gives me 76 for angle E. And now because angle F is the same, they're congruent, I know that angle F is 76 degrees. Although I could plug in the 18 here if I wanted to as well, but I don't have to because I know they're congruent. Now I'm going to use the triangle sum theorem to say that, well, 76 and 76, add those up and subtract from 180, because that will give us what D has to be. So 76 plus 76 is 152, which means that angle D has to be 28 degrees, because I could subtract that 152 from 180. Okay, so that kind of will help you on the previous problem that we skipped. That one's actually a little easier than this, I believe, because they give you the angles. All right, next, a couple corollaries about equilateral triangles. So corollary 3, it's easily provable, and that basically says that if a triangle is equilateral, if and only if it is equal angular. Okay, so if all 3 sides are equal, then all 3 angles must also be equal. And then corollary 4, extending on that, says that if each angle of an equilateral triangle has to measure 60 degrees, because if they're all equal, the only way they can all be equal and add up to 180 is if they're all 60 degrees. All right, so let's do a couple problems based on that. So we're going to find the variable of each. Let's just do B here. Okay, let's just do B, and we can work on the other ones at a different time. They just want the value of each variable, so they want x and y. Well, let's take a look at where they are. So here is our x right in here in this angle, and then our y's, there's one right here, and there's one right here. Okay, so I'm going to attack the y's actually first, okay, because I know that those two have to be equal because of these dash marks. So those two would be equal. So I'm just going to go ahead and start that way and go 4y minus 2 equals 2y plus 2. And then I can do algebra and solve this. So I'm going to subtract 2y from each side. And I'm also going to add 2 to both sides, right? So that's going to give me 2y equals 4. And then when I divide by 2, I'm going to get y equals 2. So that's part of it. Now I have to find the x. Well, the x is highlighted here in yellow. What we have to say here is that I have to kind of find what these angles might be, okay? And then I can solve for x by itself. But because, again, remember that because these two sides are equal, then that means this angle here is equal to this angle here. So I could technically say that this angle here is 6x plus 8 also. So then I also know that all three angles have to add to 180. So I'm just going to do a little bit of work up here and say that this 80 degrees plus the two angles that are 6x plus 8. And there's two of them, so I'm going to write it as 2 times 6x plus 8 because there's two of those angles. But all three of those angles together would have to equal 180 degrees, right? So if I do that, I can kind of figure out through some of that math, and I'll just kind of skip through that, that these angle measures have to be equal to 50, right? Another way to do that is to say, well, if this is 80, right, that's 80, and I know that 180 degrees in a triangle, if I subtract that 80, well, then there's 100 degrees left, right? And I would have to split that between these two angles. So 100 divided by 2 gives me 50. So that's another way to figure that out. So I know that this angle here has got to be 50 degrees. So now I can use algebra to kind of solve that one and say 6x plus 8 equals 50. And then I can subtract 8, and I get 6x equals 42. And so x equals 7. So my answers here then would be x is 7 and y is 2. Okay? So go ahead and try A and C on your own using those same ideas. And we'll, kind of go over some of those in class if we need to as well. All right? And that's it. We're going to skip the proof here. And so that is it for 4.6, and that is it for Chapter 4. So bring any questions you have with you, and we will go over them in class. Okay? Thanks a bunch.